Hello, we really had a long series of lectures there for developing the operations on a linked list. I hope you have gained sufficient knowledge to develop any custom operation on linked list data structure now. And also you have understood the fundamental conceptions of linked list. In this tutorial, I'm going to show you how we can recursively traverse a linked list. We'll develop two functions, both recursive, one that will print the content of each node from first to the last node, that means in the forward direction, another to print the contents in the reverse order. I've created another program there and taken some of the functions from the previous program just to create the linked list with some random numbers. Let's go ahead and build these print operations recursively. I have copied some of the functions from the previous program, as you can see them there. Also the structure node and structure linked list, they just remain same. We'll be using these functions just to create the linked list with some random numbers. Okay. In this tutorial, we are going to implement actually these operations, these four operations. Amongst these two are actually going to be implemented recursively. This print rec forward is a recursive function that's going to print the linked list in the forward direction from the first node to the last node. And the next one, the print rec reverse, this is going to print the linked list in the reverse order. We'll be calling these recursive functions from these two functions, the print list forward and print list reverse. These two functions are actually going to receive the linked list pointer, and they are in turn going to call the recursive operations. So these two are actually the recursive helper functions that we are going to implement there. So let's go ahead and see how we can do that. Okay, so here is the print list forward function. From here we'll just make a call to the print rec forward, and we'll be passing the address of the first node. So list ptr arrow head. Okay, that's the address of the first node that we are passing to the recursive function for the first call. And here, in case of print list reverse, here also we'll be calling the print rec reverse, and we'll be passing the address of the first node. lstptr arrow head. And actually we'll be implementing the recursive logic here in these two functions, print rec forward and print rec reverse, as I said earlier. So they are actually receiving some node's address, say p. So if the p is null, now when we do the recursion, we first of all think about the base condition, that means from where the recursion is going to bounce back, or from where, or at that point when the recursion is going to terminate. So if p is null, we don't need to do anything. Okay, if p is null, we don't have a node there, so we are just going to return from this function that terminates the recursion. Otherwise, if p is not null, that means p is pointing to a node currently. So in that case, we are going to print the content of the current node. Okay, let me do that. Since the content is an integer, we are just using %4d there, and then p arrow data, that's the data part of the node. Okay, so we have printed the node there, and now we need to call this function again so that it can print the next node. So we are calling this print rec forward again, print rec forward, and we need to pass the address of the next node because the current node has been printed. So I'm just calling p arrow next. So you can see that this is the recursive call, and this is a tail recursion, as you can see that, because this is the last statement of this recursive function. It is as equivalent as a loop. If you don't know about this recursion and this tail recursion, there is a good discussion in my other tutorial in C programming there. You can subscribe to that tutorial. It's available there in Udemy. I have a section that where I have discussed thoroughly about this recursion. Okay. Now here, so we are done with this. The print rec forward is done. Now in the print rec reverse, here also if the p is null, we don't have to do anything. So we just need to return from this function. Otherwise, if the p is not null, that means we have this node. Okay, let me just declare that p there as parameter. Otherwise, if p is not null, we need to go to the next node. Unless and until we print the next node, we cannot print this node, right? So here we cannot implement it as tail recursion. So first of all, we need to call the print rec reverse, and we'll pass the address of the next node there. So it goes to the next node and it completes the printing there. Now if it goes to the next node by recursion, then again there it will have another recursion that will actually push it to the next node, and it will ultimately stop when it goes to the end of the linked list. So when we come back, then obviously we need to print the content of this node. So it's going to be in the reverse order. So we are done. Now I'll just create a linked list there as I did here. Okay, I have initialized that. So I'll create the linked list using some random numbers. Say I will create it for 10 numbers. So there will be 10 elements in the linked list, 10 nodes will be there. They will be randomly created, I mean the data part of them. Okay, so now I'm going to just call print list forward in order to print it in the forward direction. Then just give a new line there and then print list reverse, just to print the list in the reverse direction. So we need to pass the list address here, and also we need to pass the list address here. Semicolon, printf, and we are ready to compile this program. So let's go ahead and compile that. The name of the program is linked list underscore v2. So gcc linked list underscore v2.c. Okay, we have some error there. Okay, I have a typo. lstptr. It should not be lstptr, right? It should be linked list. And this should be lstptr, as I have used that here. Okay, so we are done. Let's try to compile that again. Yeah, it has been compiled. So gcc so /a.out, and you can see that it has been printed. Oops, we have not given any space there. Let me just update that. A %4d will make it separated. So linked list underscore v2.c, compiled again, running the program. Now you can see that the first one is actually the linked list that is printed in the forward direction, and the second one is actually the reverse of the previous. So we have implemented the recursive functions to traverse the linked list there. So that's all for this tutorial, and in the next tutorial we will see how we can implement a stack using a linked list. Thank you very much.